Stargazers, gather around for some truly exciting cosmic news. Astronomers have just completed a detailed mapping of two fascinating pairs of stars located beyond our Milky Way galaxy. These aren't just any star pairs, these are what astronomers call symbiotic stars, where one star is actively consuming material from its companion. This discovery isn't just a curiosity, it's a powerful tool that could help us measure distances across the cosmos and give us a deeper understanding of the life cycle and interactions of stars. To appreciate this discovery, let's start with an astounding fact: more than half of the stars in our Milky Way are actually in binary systems, meaning they come in pairs. Though it's highly likely that other galaxies are also home to a significant number of binary stars, those stars are often too faint and distant for us to observe directly. But symbiotic stars, where one star essentially feeds off another, produce a distinct brightness that makes them easier to observe. By closely studying the orbits of these symbiotic systems, scientists can gain valuable clues about how stars in other galaxies evolve, helping us determine if binary systems in distant galaxies follow similar patterns to those we find in our Milky Way. The life cycle of a binary star system is complex and fascinating. When two stars form together, they can have vastly different fates depending on their masses. The more massive of the two typically burns through its fuel much faster, racing to the end of its life. This rapid consumption leaves behind a dense remnant known as a white dwarf, a small, dim object that packs the mass of our Sun into a space the size of Earth. If this white dwarf is close enough to its companion, its gravitational pull can siphon material from its neighboring star, creating a telltale signal that astronomers can detect even from incredible distances across the universe. Two specific symbiotic systems, Draco C1 and LIN 358, have recently been mapped in great detail. In the Draco C1 system, the stars take about 3 Earth years to complete one orbit around each other, while the stars in LIN 358 have a slightly shorter orbit of just over 2 years. These two systems represent the first full orbital measurements of any symbiotic star systems outside our galaxy. With these precise measurements, astronomers can now delve deeper into questions about how binary stars evolve in other galaxies, shedding light on how such systems form, age, and interact over time. In some cases, a white dwarf in a symbiotic system may pull in enough material from its companion to trigger a spectacular explosion known as a supernova. These explosions are immensely bright and can be seen across vast cosmic distances, making them a sort of standard candle that scientists use to measure distances throughout the universe. While Draco C1 and LIN 358 may not be candidates for supernovae anytime soon, understanding their inner workings provides astronomers with clues on how such standard candles evolve, potentially offering even more accurate tools for measuring the universe on a grand scale. If you think symbiotic stars are wild, wait until you hear about the massive stars out there. Let's introduce Uy-Scuti, a colossal star located around 9,500 light-years from Earth. Uy-Scuti isn't just large, it's utterly gargantuan. It measures around 1,700 times the size of our Sun, which means that if it were located in our solar system, its surface would extend past Jupiter's orbit. To top it off, Uy-Scuti is incredibly bright, with a luminosity around 340,000 times greater than our Sun. It's what scientists call a red supergiant, a massive star that shines with an intensity that's almost unimaginable. Stars like Uy-Scuti form in a way that is both similar to and distinct from smaller stars like our Sun. They begin as massive clouds of gas and dust that collapse under the pull of gravity. As the core heats up, nuclear fusion ignites, and a star is born. But Uy-Scuti didn't stop there, it kept gathering more and more material from its surroundings, growing larger with each passing moment until it became the staggering supergiant we see today. Even though Uy-Scuti is impressive, it's not the only giant star in the cosmos. Another contender, VY Canis Majoris, once held the title of the largest known star, with a radius about 1,400 times that of our Sun. Located around 5,000 light-years from Earth, VY Canis Majoris remains a monumental presence in the sky, but it has since been eclipsed by UI Scuti in terms of sheer size. Then there are hypergiants, a class of stars so vast that they make even supergiants look small. Take, for example, Stephenson 2-18, a hypergiant located approximately 20,000 light-years away from us. Stephenson 2-18 has a radius about 2,150 times that of our Sun and shines with the incredible brightness of about 7 million suns combined. And if that isn't enough to blow your mind, consider that these cosmic giants are dwarfed by an even greater mystery, the Great Attractor. This mysterious force lies beyond our galaxy and seems to be pulling entire groups of galaxies toward it. Some theories suggest that the Great Attractor could be home to a massive cluster of hypergiants, although the true nature of this phenomenon remains one of astronomy's biggest mysteries. Now, let's turn our gaze to a star that's quite literally heavy metal. Scientists recently discovered a unique type of star called a heavy metal subdwarf, and yes, it's as rock and roll as it sounds. This star has an astonishingly high metal content, containing about 10,000 times more iron than our Sun. To determine this, astronomers used a technique called spectroscopy, where they analyzed the light emitted by the star to determine its composition. By studying the light spectrum, they could identify a remarkable concentration of heavy metals, including iron, nickel, and chromium. But there's more to this heavy metal subdwarf than just its composition. It's much smaller and cooler than our Sun, and it's ancient, almost as old as the universe itself. By studying this star, scientists hope to learn more about the early universe, as it offers a window into conditions that existed shortly after the Big Bang. Since this star has likely been around since the universe was very young, it carries with it a unique history of cosmic evolution, potentially helping us understand the first stars and galaxies to form. Speaking of iconic stars, let's discuss Vega, one of the brightest and most beloved stars in our night sky. Located about 25 light-years away in the constellation Lyra, Vega is practically a cosmic neighbor. Though it's a relatively young star at just a few 100 million years old, Vega shines with a brightness that has captivated human observers for centuries. In terms of temperature, Vega is blazing hot, with a surface temperature of around 17,000 degrees Fahrenheit, almost twice as hot as our Sun. If you think it's hot on Earth during summer, imagine standing near a star like Vega. What's even more intriguing is that Vega is surrounded by a disk of dust and gas, known as a debris disk. This disk resembles the protoplanetary disk that once surrounded our young Sun, out of which our solar system eventually formed. Scientists believe that studying Vega's debris disk could offer insights into the early processes that shape planetary systems. Additionally, Vega is a known source of cosmic rays, high-energy particles that travel through space at nearly the speed of light. While scientists are still trying to pinpoint the exact origins of these cosmic rays, they know that Vega is one of the stars contributing to this mysterious phenomenon. Vega has also left its mark in popular culture, appearing in movies, books, and other works as a symbol of brightness and discovery. It's no wonder that this brilliant star continues to inspire both scientific exploration and human imagination alike. If this journey through the stars has sparked your curiosity, don't stop here. Give this video a thumbs up, share it with friends, and dive deeper into the wonders of the universe by exploring more of our cosmic mysteries. There's always more to uncover in the night sky.